Hello everyone, welcome to today's lesson. Today I will try to present about week 5 part 2 video, which is operation of manual transmission in transaxle. Last time we will try to see about the first part of chapter 3, which was focused on the transmission system or the manual transmission and its classification. In this part we will focus on first the operation of manual transmission. When you say operation of manual transmission in transaxle, of course the target of manual transmission in transaxle is almost the same, because both are helpful for transferring power from the engine to the drive shaft. When they transfer power, they perform different tasks, like simply they multiply the torque or increase the speed or change the direction of rotation. But the transmission transfers power to the drive shaft and the transaxle, which means transfers power directly to the drive shaft, because it's used for the compact drivetrain arrangement. If you observe the previous drivetrain video first, or the drivetrain arrangement video, which means the front engine front wheel drive or rear engine rear wheel drive. When we see the layout of manual gearbox transmission in transaxle, like if you observe the first one, clearly shows that the transaxle gear set. In the transaxle gear set, what you are observing is simply this one input and this one will be output, so they didn't have any counter shaft, or they didn't have any intermediate shaft in between. But in this case, if you observe, there is input and there is counter shaft, and at the top it will have output or main shaft, so which means they will have this difference only. And this transaxle includes the gearbox and the differential part as a compact part or design. Before we proceed to the detailed operation, let's have some concept on how power is flow from the gearbox. Especially if you observe, this one shows us the manual gearbox, this one is the input shaft, this one is the counter shaft, and this is the output shaft. So they integrate like 3 shafts. So for example, here the power will flow in this part, like the power is come from the engine or the clutch disc from in this direction, go downward, and it will get the gear, because this one is slide mesh gearbox. And in this part, if you observe, the power is flow directly without passing through the bottom part, because the bottom is open here, because the gear is slide in this direction. So we call this one direct drive, and this is applicable for all gear except direct drive. When we see the power flow on the transmission, let's see some concept, and I will give you some question to analyze by yourself, and you can answer this one online for my email or directly with the platform. If you see this one, this is the input shaft, then this is the counter shaft, then here is the output shaft. Now always, if you observe this picture, always if the driving gear is small and the driving gear is large, we will obtain torque. That's why this one is first gear. When the size increases, the speed number increase. We call this one, this part, underdrive. And when we come to this one, it will almost become overdrive, because this gear is bigger than the driven one. The same is true for the gearbox. Like if you observe this one, simply this one will be the counter shaft, which is the drive, and this one is driven. So the same arrangement is here. So if you observe this one, simply to know the flow, you must know the drive and driven gear, and you must identify which one is large or which one is small gear. So in this part, if you observe, this is very small, so this is first gear. But the question that I want you to answer is the first one: why this pass through in this part, and why it creates a circle in this area? Because why it doesn't go through in this direction? Here in the second, observe it go downward again straight, or it's not, I cannot say straight, it cannot go to at the center, but it go up and turn to the right side, then down. What does it mean? This will be your assignment. Let me give you some clue for this. Just consider the synchronizer arrangement, and you will give me a detail about this one. You can write simply on the comment part, or you can send me a message for this part. So by the way, let's come to my point. And the input shaft here, the bottom, then it will turn U, then go out to the output shaft. In the second gear, it will, this was the first, then next it will become to the bigger gear than this one, then it will go through and directly the output. The same if you follow also the third gear. Again, this was the first, this was the second, then the power come from the input shaft, then proceed to the counter gear, then the counter gear is rigid here, and it will transfer to the gear, and then it will circle output shaft. The one difference what I want to show is, if you see the force, it will go straight here. It doesn't go through the counter shaft. Why? Because we call this one direct drive. Simply this shaft and this shaft are integrated by means of positive clutch, like this one. You see? Like this one, it was open here, but in this case they are engaged, so the power will be directly flow in this part. That's why the fourth gear we call this one direct drive. And if you observe the fifth gear, it's out of the intermediate shaft, in the intermediate plate, and if you see the size, it is very big, and this one, the output side, is small. We call this one OD overdrive. So 1 to 3 are underdrive gears. This one is direct drive. This one is overdrive, which means the engine torque will be multiplied and go out, but the speed will be reduced because torque and speed are inverse. But in this part also, we call direct drive, because directly the engine torque and speed will be output to the gearbox, I mean to the drive shaft. We call this one direct drive. But in this case, it's the inverse of or the vice versa of the underdrive, which means the input speed is very low but the output is higher, because the gear they use is somehow bigger driving gear and small driven gear. In this part, what you are observing here is in the revolver view of this picture. In this part, 3 gears are meshed for creating reverse, because this one rotates counterclockwise, the mating gearing opposite, but this and this will have the same rotation. So which means to change the direction of rotation the vehicle, to move forward or backward, for the forward it uses 2 mating gear, for reverse it uses 1 extra gear. We call this one idler gear, reverse idler gear, to change the direction of rotation only. If you are clear with the power flow of transaxle, let's see the power flow. I mean, if you are clear with the power flow of manual gearbox, let's see also the transaxle. In the transaxle, just let's try to see the first, second, third, and fourth gears. This one is the input shaft, which is mounted to the clutch. So the clutch is already here, the differential is here. That's why we call this one transaxle. Simply transmission, and we will obtain axle here. It doesn't have any propeller shaft in between. So this one is the input shaft. Directly it goes to the output one. So input and output, it doesn't have any counter shaft here, which means the smallest gear at the top will be the lower gear and the biggest will be the higher gear. When we say lower gear, lower speed gear and the higher torque. Again, in the second part, if you observe, it's the next, which means somehow bigger than the first. We call this one second gear, and it will transfer to the wheel by means of differential. The third gear, again, it uses the next gear, which is bigger than the second, and transfer. In this part, what you need to know is we cannot create direct drive by means of connecting shafts directly, because these shafts are not in one line. They are parallel one each other, so we cannot make straight line in both parts. To make direct drive, what they use is the same number of T's gear. If this gear and this gear is the same number of T's, we can obtain simply direct drive in transaxle operation. Next, let's try to see about the critical concept, which is gear ratio. When you say gear ratio means, when you say gear ratio is, of course this gear ratio will have relation with the number of T's, the speed effect, or the speed multiplication or torque multiplication effect. So when you say simply gear ratio, is the ratio of the number of turn the output shaft makes when the input shaft is turned. So we call this one speed ratio, yeah? And again, gear ratio is the ratio between the number of T's on the two gears meshed together, or two sprockets connected with a common roller chain, or circumference of two pulley. That's why in CVT, continuously variable transmission, it uses pulley, and it will multiply torque. In manual gearbox, it uses gears for the sake of torque multiplication. Also in bike, it uses chain with sprocket to increase or reduce the torque. So this is the definition. The gear in transmissions are selected to give the driver a choice of both speed and torque. Always the lower gear allows for lower vehicle speed but more torque. Higher gear provide less torque but higher vehicle speed. By the way, this term will have inverse understanding with Amharic, because in Amharic, if you say higher gear means this will have too much torque, or they call it heavier gear. So in this part, the critical or key concept is the torque input and the torque output will vary, or the speed input and the speed output will be vary by changing number of T's on this gear, or the diameter of these gears, or the diameter of the pulleys, or the sprocket. You can understand, or you can differentiate from different perspective. If you observe, this one is reduction gear or gear reduction, because the driven gear is very big and the drive gear is very small. In this part also, we call this one OD, over overdrive, which means this gear is, the drive gear is very big and the driven gear is small, which means in this part 1000 RPM is reduced by half, and it will become 500, which means it will reduced, but the torque will be increased. If I make it 4, the difference will become 4 times. Again, this one, if you observe, this was 20, but the torque reduced and the speed increase. By the way, this factor in real condition is that's why when we use higher gears, the engine cannot handle the load of vehicle, and it will off, or the engine will vibrate. At that time the driver will be downshift. So this is one concept. If we see the gear ratio calculation, obviously gear ratio is the number of driven gear over the T's number of driving gear, simply by putting these gears or by counting T's of number of T's. We can calculate and obtain the result. Based on the result, we can also able to calculate the speed ratio, the torque ratio, and the gear ratio. So from the gear ratio we can obtain the torque ratio and the speed ratio. If the transmission is equipped with intermediate or counter shaft, we can have different calculation. For example, ratio of the gear as a total number of driven gear divided by total number of driving gears, which means if we see number of gear of 2, 4, let's go back to 1 point. Sorry. If this counter shaft, first gear, second gear, then third, fourth, you see, or first, this one first, second, third, fourth. That means this is the drive, driven, drive, driven. 1 and 3, 2 and 4 are common, so that's why it uses this principle here. You see, 2 and 4 and 1 and 3. So the total number of driven gear over total number of driving gear. So driven over driving. 1 gain from the input shaft, and this is the counter shaft, and this one is obtained from the input gear, and this is the output final gear. So this is how we calculate the gear ratio for this part. And in some aspect, to give you some clue, some typical gear ratio examples. For example, in most vehicle, the first gear range will be 3.1 to 1 to 4.2 to 1 at different engine models. That means it will have this much range. If we observe second gear, 1.7 to 2.5, which means 1.7 to 1 and 2.5 to 1, which means at different engine model. When we come to force or overdrive, if you see, this gear will be very big and this one will be small. So the speed and the speed will reduce, the torque will be decreased. In this part we call this one underdrive, and we call this one overdrive. In the case of reverse gear, if you observe 3.3 to 4.5, which means for the same design, the first gear is 3.1 but the reverse is 3.3. If you see some drivers in some difficult condition in muddy road or heavy hills, what they did is they use reverse gear instead of first gear, so the vehicle can be move out from that obstacle. The reason for that is, if you observe, the reverse gear will have around 0.2 gear ratio difference than the first gear, so it's better. When we come to the gear selection mechanism, in manual drivetrain, the driver controls every action by considering the engine speed and the load, the engine load and the vehicle speed. At the same time, in automatic transmission, these tasks are performed by the electronic control unit or the hydraulic pressure in the case of conventional hydraulic and electronic control transmission. This gear shifting mechanism will have element. We can categorize this element into 2 parts. Almost in many vehicles they will have different classification. If you consider passenger vehicle, they will have internal engaging element and external engaging element. If we say internal engaging element, it includes shaft forks, synchronizer, locking device, the discs and the brakes are included in this part. External part engaging element, mostly they are used for selection, shift level system, in-hole cable and the gear shift lever. So they transfer the driver effort, but the internal engaging element, they will lock one gear from another or one shaft from the gear to the shaft to gear. So this is one thing. The type of gear shifting control mechanism. We can categorize this gear shifting mechanism by location of gearbox and based on number of rail. According to the number of gearbox, we can classify as location of gearbox. Sometimes in different arrangement, the gearbox can be separate from the driver area, seat area. So we call this one remote type of gear lever control. And if the driver, seat and the gearbox is directly controlled, direct type of gear lever control based on the number of rail. We will have multi and single rail selector rod mechanism. To show you this one, simply according to the location of gearbox, if you observe this one, the driver hold here and directly move the internal engaging elements. But in remote control or remote shift type, the gearbox is here, the driver seat is here, so they are connected by means of cables. And when we see the number of rail, if you see, it will have 1, 2, 3 rail for each forks, but in this case they use common rail. When you say common rail, they use single rail, and this single rail includes too much fork. The next one is the shift interlocks mechanism. This shift interlock mechanism maybe we'll use or see as shift detent mechanism and shift interlock mechanism. When we say shift detent mechanism, as you observe in this picture, they will have two benefits. One, it keeps the selected gear in position, and it gives sense for the driver to know whether the gear is engaged properly or not. This will have spring-loaded notch and the spring-loaded ball and the notches, so it will hold in gear. Sometimes if the gear is if the shift lever is out of gear where we are driving, the problem will be this detent mechanism. And the interlock mechanism or shift interlock mechanism, it prevents simultaneous engagement of two gears. Let's see some video on these parts.
Manual transmission, detent and interlock operate.
You can if you see this video, simply when the driver shifts, it will move, so it requires some extra force to move this one, so the driver feel whether the gear is neutral or on gear, you see. So it gives some sense and puts the gears, the shift lever on gear. On the next part, this is interlock pin. It prevents the engagement of extra gear. For example, at this condition, if you observe, if this it locks, it allows to move this rail, but it locks this one. It cannot move anymore. But if we make it neutral, now after this, we can move this or this optionally. But if it select, what will happen? It prevents the movement of this rail by locking. So we call this one shift interlock mechanism, which prevents the engagement of two gear at one time. Okay. In the next part, misshift prevention and misshift prevention and misshift prevention upshift, we call this one. The first part is misshift or shift level system. It always makes neutral the gear. if you observe when we move the selector lever, always we will obtain in neutral part. So it makes by these two springs and these bolts. So the spring always push this one at the center to make free this shift lever housing. So simply this is misshift always. If you observe to change the gear, we start from neutral and we will pull in one direction by to select the appropriate gear. That's why we call this one misshift prevention. The next one, reverse one-way prevention or pre-block mechanism, we call this one. It prevents the moment of reverse shift interlock to the fifth gear. Look this one. What will happen if the driver shifts from fifth gear to reverse? Because in some arrangement the reverse and fifth gear are aligned in one direction. So what will happen if the driver pulls from the front to the reverse? What happen? The gear will be damaged. There will be critical effect, or maybe the vehicle will be rollover. So to prevent this one, it uses a snap ring or some mechanism to prevent shift from fifth gear directly to the reverse. So we call this one reverse one-way mechanism. Thank you for your attention. I will hope you enjoy this video. If you have any question, comment, and suggestion, you can send my contact number. Thank you. Have a nice time. Bye bye.